Howdy, folks, and welcome back. So last time we had talked about the mutate command, which allows us to create new columns. And because a lot of times we want to do some feature engineering. We want to say, okay, well, we didn't have access to the miles per hour time for the flight. So how fast was the flight going? But we had distance and we had the time elapsed of the flight, so we could engineer to say, okay, well, this is as the crow flies distance, so the distance on the ground, even though the plane is going up and down through the air, the speed we can estimate it as well. The distance across the ground was this much. It took this many minutes to travel, so therefore we could find an estimate of the miles per hour. So that's our mutate command, and that allows us to create new columns. Well, so group by and summarize, a lot of times we need to find some calculation about the data, but specific to a subgroup within the data. So if you have a clinical trial with folks in different treatment arms, then you could say, all right, well, I need to find the efficacy of my intervention, but I need to find that differentially between treatment arm 1, treatment arm 2, and the control, okay? And so what you would want to do is you would say, all right, well, I need to first group the data by which treatment arm, and say, okay, I'm going to group these samples by which treatment arm they belong to, and then summarize the effectiveness measure of whatever it is. So maybe we're saying, okay, we want to measure blood pressure before and after. So then you would have a blood pressure before feature, you would have a blood pressure after feature. You'd use mutate to find the difference in the systolic blood pressure. And then you would say, all right, let's group by the treatment arm, summarize the average distance or the average difference in the blood pressure based on the treatment arm. So like, okay, well, hey, look, treatment 2 had a larger decrease in blood pressure compared to treatment 1 and control, something like that. And so this is how we would do these sorts of data wrangling, data massaging exercises, is with group by and summarize. So here's an example here. If we wanted to find just the average delay, so this is across 337,000 rows, the average delay is only 12 and a half minutes, if you will. Note here that if there's even one missing value in 337,000 records, then the whole average becomes missing. So you use na.rm equal true as an option inside the mean function. But so what we're doing here is we're saying find the flights and then summarize the flights by creating a value called delay, which is the average departure delay. So on average across 12,000 flights, or I'm sorry, not 12,000 flights, 337,000 flights, we've got a departure delay of about 12 and a half minutes. Okay, so and then we're going to take a brief pause. Because there was missing data, we say, okay, well, let's remove all of the flights that were canceled. So we're going to create because the NAs, the delay, is from flights that got canceled. So, and again, going back to the idea of data science, we've got to have code, we've got to have math and stat, we've got to have domain knowledge. We needed to read about the data to find out why the NAs were there. The NAs were from canceled flights. We got that from our domain knowledge. So we create a data set. We say, give me the flights data set, and then filter to all of the rows where is.na, i.e. is missing, where the departure delay is missing, is not true. So this exclamation point is going to reverse that true and false. So right here, this is going to create a logical indicator of trues and falses, and there's going to be trues every time the departure delay is missing. Well, we don't want to keep the rows where that's true. We want to keep the rows where that's false. So we reverse it. And now we have a vector of about 337,000 trues and falses, where the true value means that the departure delay is not missing. The same for arrival delay. I'm a little worried about what would happen if a flight had a departure delay but didn't have, but this one was missing. I mean, did the flight just evaporate in thin air? I have no idea, but we're removing both. We're just saying, okay, if there was missing departure delay or missing arrival delay, that means the flight was canceled. We're going to remove those flights from our data set. And we're going to perform some calculations on the flights that weren't canceled. So we have the not canceled we have the not canceled data set, and then we say, okay, well, is it that we've got departure delays because perhaps like there are certain examples, like our subject matter expert could say, well, we're really interested in wind resistance, or maybe there's an issue in air traffic control at certain airports. So what we would do is we would say, let's group by the destination airport. So all of the flights that are going to one particular destination, and we look at the arrival delay. And so that's this summarize. So we're going to group by the destination airport, and we're going to summarize all of these values. So there's 337,000 rows, but we don't know how many groups there are. Apparently, there are 104 destinations. So there's going to be 104 different groups of these 337,000 rows. And then we average within those groups, and we say, give me the average arrival delay. Again, I didn't have to include na.rm equals true because we've already removed all the missing values here. And then residual delay. So let's find the difference between the delay compared to the average delay. So the average delay across all of these groups could be, I don't know, let's hope that on average we're close to, I don't know, 10 minutes or 12 and a half minutes or something. And so the residual would be the difference between the actual observed delay for the observed average delay for these destinations and the average delay across all destinations. And so we have that whatever LEX, maybe this is, I have no idea what airport this is. So whatever airport this is, LEX, PSP, I don't know where. I guess this is Anchorage, I suppose, and there's Honolulu. So it looks like Honolulu on average shows up about they get into their destination a few minutes early in terms of the delay, but compared to the average delay, they're actually 10 minutes earlier than average. Because the average delay is somewhere around 12 and a half minutes. So even though they are only showing up a minute and a half early, if you will, but compared to all of the other flights, they're even showing up a little bit earlier than that. So one comment here, we're using the group by command. There is another option. We could have specified the by argument directly. I'm sorry, not in the mutate command. We can put a by argument in the mutate command, but we could have specified the by argument directly in the summarize command. And that's by typing .by, and we would say summarize .by equals destination or something like that. So this is another way to do this. You can choose either way. Just understand that if you assign groups up here using the group by command, they could potentially survive beyond the summarization. So if you group by year and month and day, but then only average over the month and day, then the summarize will finish will summarize over the month and day, but leave the grouping for the year. Sometimes that's what you want. Sometimes it's kind of an unexpected byproduct. So just be aware of this. And if you're sure that you don't want the grouping to persist afterwards for any other calculation, then you can put the grouping inside the summarize command. But if you're thinking of doing like just a whole pipeline, a whole analysis where each step in the analysis needs to have grouped calculations, then just group the data set up above. So this gives you a little bit of flexibility. And if you're not 100% sure which one to use, I would say I actually don't have an opinion on this. It's going to be a case by case. I think my default is usually to use group by, and then to perform whatever summary calculations I need to. And then if I'm worried that the data set is still grouped, I use a function called ungroup, which will turn the groups off. But there's pros and cons of either way. And I would say if you want to learn more, there's a documentation page in one of the RStudio help manuals, or tidyverse help manuals, on when to use group by versus when to use the .by argument. So we've already talked about this before, and I've already tried to sell you on this idea of chaining operations together. Actually, this is probably a good place to pause. So let's pick back up and do something kind of cool where we chain a whole bunch of operations together that we've learned. So I will see you next time.